So if you have to graph an inequality in the Alex system, just make sure the points you choose are dots that are exactly on the line. Because if you try to pick some dots that are close but not quite, Alex will mark them as incorrect. So we've got this inequality. Note that there's no line underneath, so that means that the inequality should have a dotted line when we graph it. Okay, but for starters, let's look what the actual line would be. You know, like as if it was a regular old equation. You might do this with the slope-intercept form method, where the -3 is the y-intercept, so we put a dot at -3, and then the slope is -1, so that means we go down one to the right one, down one to the right one. Or another way of graphing graphing any equation is you could get some points for the equation. Okay, like if I plugged in -1 for x, if you put -1 makes a positive 1, 1 minus 3 makes -2. So -1 common -2 is a dot on our graph. Okay, so that's a different method, plugging in some values. If you plug in 0 for x, you get out -3 for y when you solve that equation. That's a dot that we already have. Okay, just make sure your dots are exactly on the line. Okay, and so to graph the inequality, let's try clicking the line tool. We want it to be dotted though. So here, let's pick any of those 2 points, and then I think this will switch it. Good, yeah, it needs to be dotted like that. Okay, because it doesn't have the or equal to symbol underneath the greater than symbol here. And now we just need to know which side to shade. Should we shade this side or this side? It's one of the two. Oops, I don't know how to get rid of it. Oh no, okay. Luckily I have my points here. -1, -2, 0, -3. Boom, boom. Oh, don't want to do that yet because, no wait, there we go. Dotted line. Okay, so now let's figure out which side to shade. And you can do that by plugging in a test point. Like this point 0, 0 is definitely on the upper right half of this graph, right? There's an upper right side and there's a lower left side. So if we plug in 0 for x and 0 for y, and if we come up with a true statement, then we know this side is the solution. But if we plug in 0 for x, 0 for y, and this side, and it does not come up with a true statement, that means any other point on this side would not be a solution, so we have to shade this way. Okay, so here's the inequality. Let's plug in 0 in for y, 0 in for x. So we get 0 is greater than -3. That's a true statement, so we shade this side.